With Ethos, there's usually several different methods you can go about setting up your model template to use the various model functions for your different models. I tend to set mine up a little bit differently than standard because I often share my model templates with other people, and I want them to be able to easily move the switch functions from one switch to another switch. So I make heavy use of two features of Ethos, one called the Logic Switches and the other called Vars, which is variables. So on my home screen, you can see I have my throttle cut is showing as active, and when I take off my throttle cut
off,
my throttle becomes active. So throttle cut off,
throttle cut on,
throttle cut on. I also have other callouts set up, for example, my flaps.
Flaps half, flaps full, flaps half, flaps up.
Stabilizer modes.
Stabilize, manual, stabilize, self-level mode.
Gear.
Gear down, gear up.
And dual rates.
Low rate, high rate.
And the way I set my model up using the logic switches is basically I assign all of my switches to different logic switch conditions here, and then I feed these logic switches into the mixes and other parts of the system. So for example, my gear down is looking at SF switch around 100%, which is up. So I'll toggle that. You can see it becomes bold and active. And when it's at negative 100, that logic switch becomes inactive. For my flaps, it's going to be on a 3 position. So I have negative 100,
flaps half,
0,
flaps full,
and positive 100.
Flaps half, flaps up.
Throttle cut uses a little bit of a different setup because I use the not operator. So when SG is not at 100%, my throttle is cut. And in this case, towards the back is negative 100, so it's active, and
throttle cut off.
Positive 100 means that that logic is no longer valid, so it turns off.
Throttle cut on.
With these different logic switches, you can see here I also have my low rates and self-leveling. I use these for two different things, basically. One is for all of my audio callouts. So here you can see, for example, throttle cut, gear, rates, flaps, and my level modes, self-level modes. So when I toggle my flaps,
flaps half, flaps full,
it
flaps
calls out the
half,
different flap
flaps
positions. And in these logic switches, my active condition is set to the logic switch flaps up, for example, which logic switch flaps up is SB switch at negative 100%. So if somebody wanted to move all of the flap functions from B switch to C switch, all they would have to do is change them here. With the logic switches, I also use them in the mixes settings. So for example, you can see here that I don't actually assign the switches as the source values for any of my mixes. I'm using all of logic switches. So for example, my gear down logic switch, which is SF
gear down,
at 100%,
gear up, gear down, gear up,
is feeding into a channel here for gear, channel 5. So for my source, I've chosen logic switch gear down. And when that becomes
gear
active, you can see I actually have it reversed here
gear up,
to make the correct movement of the landing gear.
gear down, gear
But it
up.
will actually toggle the channel output according to the logic switch, which is feeding into the source. For the flaps and the stabilizer modes, because they're on 3 position switches, I have to use VARs in order to get them as a source. So over on my vars, for example, I have my mode var, which is looking at the logic switches that I've assigned to this SE switch. So under logic switches, you can see SE at -100 is self-level, at 0 is stabilization, and at
manual,
100 it toggles on my manual logic switch. And over on my mode var, when I toggle into manual, you can see that the value here is +100.
stabilize,
When stabilization is active, it's 0.
self-level mode,
And self-level mode, which is just going to be when neither of these are active, it will default to this option here, is -100. Then I feed this mode var into my mixes, channel 14 for example, by choosing source vars mode var. And as you can see down here on my output,
stabilize,
as I toggle
manual,
that switch,
stabilize,
it's referencing the mode var, which is referencing my logic switches,
self-level mode,
and setting the value according to that switch position that I've defined here.
manual, stabilize, self-level mode,
And likewise, over here on my special functions, I've set my active condition for my audio callouts to be the logic switch that goes along with that callout. So if somebody wanted to move the stabilizer functions from this SB switch to SA switch, they would only need to change these 3 items, and it would change the audio callouts and the mixes accordingly. Now, typically what people will do is they'll go into the mixes and assign the switch as the source, and then they go into the special functions and assign the switch as the callout. And then if somebody wants to change it, then they have to go to all these different places again and reassign those switches about 9 different times. So by doing it all in logic switches, it's much easier to share this model template and have somebody be able to reconfigure their switches to whatever layout that they want. So I'm going to kind of step back a little bit now that I've shown the basics of how I've set this, how this model functions. I'm going to step back and show a standard model setup. So I'll create a new model by going to model select and add a new model. I'll just choose airplane, non-stabilized receiver. Actually, let's choose a stabilized receiver such as TD-SR18, for example. 1 channel for the engine, 2 channels for flaps. We'll just walk through the rest of this. Gain, we'll just assign it to a pot, for example. For the stab mode 1, normally you'll just assign this to a switch like this. And we'll just call this model as demo, for example. So here on the mixes page, first thing you would usually do is come into your throttle setup, set your throttle cut to a switch position. Actually, let's go SG down or up. So throttle cut on a switch. You would set your stab mode 1 on a switch if you don't do that at the beginning. You would set your flaps on a switch. And you would do your dual rates on a switch. So we'll add a new rate. We'll say this 80%. And we'll actually, let's do it like this. SD up. We'll long click on this and say invert. So SD up will be 100% and not SD up will be 80%. Again, this is just an example. Then you would come over into your special functions, add a new function for your play audio. You would say SG up, enable it, set this to your throttle cut, and on.
Throttle cut on.
Then you would maybe just clone
Throttle
this,
cut on.
change it to SG down, throttle cut off,
Throttle cut on. Throttle cut off. Throttle cut on.
and you can see here that it's assigned to my switch position, SG, up or down. And you would keep setting up all of your audio callouts, for example, your
Throttle cut off.
high rates,
High rate. High rate. High rate.
low rate,
Low rate. High rate. Low rate. High rate.
again tied to switch position, your
Low rate.
different stabilizer modes. So I'm not sure if I have these here. Let's see. This would be self-level.
Self-level mode.
Stabilization mode.
Stabilization on. Self-level mode.
And manual mode.
Stabilization on. Stabilization on.
And again, I'm just tying all of these to the actual switch position here.
Stabilization on. Self-level mode.
And let's say you also have your flight modes here for
Throttle cut off. Throttle cut on.
throttle cut, self-level,
Stabilization on. Self-level mode.
stabilization,
Stabilization on.
manual,
Manual. Throttle cut off. Stabilization on. Self-level mode.
So again, now if I needed to share this model file to somebody and they don't want their stabilization modes on this switch, they want them on B or on A switch, for example, they'd have to go into mixes, reassign the mix to A. They'd have to go into the audio callouts under special functions, change each of these to now the 3 positions of SA switch.
Stabilization on. Manual.
And then for the flight modes as well, have to change all of these as well.
Stabilization on. Self-level mode. Stabilization on.
So as the model becomes
Manual.
more and more complex, if somebody wanted to change the switch configurations, it becomes more and more tedious having to go into all of these various areas to remember to change it on the mix and change it on your special functions and change it on your flight modes or wherever else that all of these switch positions have been manually programmed in. So instead, that's where programming with the logic switches becomes a better option,
Switch warning.
because you can come in here, set all of your switch positions on the logic switches,
Manual. Stabilize. Self.
and then everything else in the system is tied to those logic switches. So you don't have to reconfigure your each and every switch position. So I'll kind of show how that is set up from a scratch. So I'll create another new model, airplane with the stabilized receiver, 2 channels for the flaps, traditional tail. In this case, I'm just going to skip through assigning my gain and my stab mode. We'll just assign them later. So I'll call this one demo logic. So now what I would do is I would come over to my logic switches, and instead of setting my throttle cut here as an actual switch function, I'm going to create a logic switch. So I'll say logic switch, throttle cut, and it'll be my G switch for my source, and the value will be -100. Actually, you can just click on that and go minimum. So when SG is at around -100, that's what the squiggly means, is that it's around that value, the logic switch becomes active. Now I can come over here to my mixes, throttle cut, and assign that logic switch as my throttle cut. And also I can go to my special functions, add a new audio callout. Active condition will be the logic switch throttle cut, and I'll say play file for throttle cut and play file for on.
Throttle cut on.
So I'll clone this now.
Throttle cut on.
And in this case, what I'm going to do is click on this and then long click on it again and choose invert, which means not throttle cut. So when I'm not throttle cut, I'll say my throttle cut is off. You can say throttle active or whatever voice call out you want.
Throttle cut off. Throttle cut on.
And on my throttle mix,
Throttle cut off.
active throttle,
Throttle cut on.
throttle cut on. Next, we'll do our stability modes. So since this is a 3-position switch, I'll need to add 3 separate lines. And I usually put my stability modes on the SE switch. So for my source, I'll choose SE switch. I'll set my first position, which is -100. So you can see when it's all the way back or all the way away from me, it's -100 and the logic switch becomes active. And usually this will trigger the self-level mode. Now you can also reassign these to be anything. You can have your -100 all the way back be stabilization and then self-level in the middle, and complete manual all the way towards you. That's kind of the benefit of using the logic switches as well. So I'll create 3 different options here. Self-level, stability, SE at 0 will be stability, and then manual. With it all the way up, which is positive 100. Under special functions, I'll just keep cloning these audio functions and editing them as necessary. So for my self level, actually I need to now take off the invert. Rearrange all of this. Self level. So now
Self-level mode.
when active condition of self-level logic switch, which is SE at negative 100, becomes active, it plays my self-level.
Self-level mode.
Let's say stab mode will play stabilization on. And manual mode will trigger the manual audio call out. Now this is just
Stabilization on. Manual. Stabilization on. Self-level mode.
going to set up, this is just setting up the audio callouts. I still need to get these logic switches to actually do something on channel 14. As you can see, it's currently not doing anything.
Manual. Stabilization on. Self-level mode.
So this is where the vars comes into play. So I'll add a new var. I'll call this the mode var. The values down here for the first one, actually I don't want negative 500. So what I'll do is I'll increase my multiplier to positive 100. And I want negative 100. So let me go back the other way. And then I'm going to add another value tied to my logic switch of stab mode. And this will be 0. And then one more logic switch, or one more row tied to my manual logic switch, which will give it the value positive 100. So as you can see, with the switch in the back position, it's neither of these are active logic switches, so it's using negative 100.
Stabilization on.
In the middle, it toggles on the stab logic switch, which sets that value to 0.
Manual.
And all the way up toggles the manual logic switch, which sets the value to 100. Now I can use this mode var.
Stabilization on. Self-level mode. Stabilization on. Manual.
And feed that into the
mode.
source of stab mode channel 14. So under the mixer, stab mode 1, source, I'll use vars mode var. And now as you can see,
Stabilization on. Manual. Stabilization on.
now it's
Self-level
actually
mode.
changing the
Stabilization
value
on.
of that
Manual.
channel
Stabilization on. Self-level mode.
as I toggle the switch. For your flaps, again, because it's going to be a 3-position switch, it'll pretty much be the same idea. So under logic switches, I'm going to create 3 more logic switches. This one will be, first one will be flaps up. We want the A about X. switch SB about -100, which is up, and that's going to be active in that condition. We'll clone that, edit. We'll set this to flaps mid at 0%, which is the middle position of the switch. And clone it one more time. And this will be flaps full at 100%. So you can see SB -100, 0, +100. But again, that's not tied into my mixes yet. So I'll create another var called flaps var. And same thing, we'll go -100, flaps mid will be 0, and I keep setting it to default, which is wrong. And logic switch flaps full will be +100. And I haven't set up my audio callouts yet either. So let's go back and set those up. So I'll just create these from scratch. Play audio, enable, active condition, logic switch, flaps up, add a new line, scroll down, and we'll go flaps up. And then add a new one. Oops. Play audio, enable, active condition, logic switch, flaps mid, flaps mid, play file, there's flaps half, and one more, add, play audio, enable, active condition, logic switches, flaps full, add a new line, play file, flaps full. So
Flaps half, flaps full, flaps up, flaps half. Flaps half, flaps up.
now, to get that into my flaps mix here, I'll just set the input in this case to vars and flaps var, and as you can see,
flaps full, flaps half.
now it's
Flaps up, flaps half, flaps full, flaps up. Flaps half,
actually
flaps
affecting
full,
the
flaps
output
half,
value of
flaps
that
up.
channel. In this case, I don't have any slow set up, but you would just add that in here.
Flaps half, flaps full.
Now there's an alternative way of doing even this here. So let's say you have your flaps up and flaps mid set. What you can actually do is, instead of setting up this third switch, you can just edit this and use the OR option and say logic switch flaps up or logic switch flaps mid, and then invert it. So what that means is when it's not flaps up or flaps mid, that becomes flaps full.
Flaps half.
So flaps mid, flaps up.
Flaps half. Flaps
And
full.
when it's not flaps up or not flaps mid, this flaps full becomes active. And you can also do the same with the manual stabilization mode. Instead of having SE assigned 3 times, you can edit that, make it an OR option,
Manual.
and say when logic switch self level or logic switch stab, and then invert, which means when it's not self level or stab,
Stabilization on. Manual.
you're going to be in manual mode.
Stabilization on. Self level mode.
So this is one way that you can use logic programming in a way to build your model templates that makes them easy to share with others, so that if they don't want their stabilization modes here, all they would need to do would be change these 2 options here, and everything else in the model template will change accordingly. All of your audio callouts, all of your mixes, your flight modes, everything else that's tied to those logic switches, it will filter down the line and make it a much easier reconfiguration. Now, one other thing that I want to show here too is that I didn't set up
Throttle cut off.
my
cut off.
throttle cut audio functions to be on what's called the system event. In this case, I set the active condition to the logic switch that I'm using. But one of the neat features of ETHOS is that you can actually use what's called system events. So when your
Throttle cut on.
throttle cut becomes active, it will trigger that. And then you can also choose system event, throttle cut,
off.
and then invert that just like we did before. So when it's not throttle cut,
Throttle cut off. Throttle cut on.
so in this case, it's not looking at the logic switch anymore. It's looking at one of the built-in system events that triggers because we've already assigned our logic switch into the throttle cut here on the mix. And then the way that a 2-position switch, such as your gear, would be programmed in, first you would create your logic switch. So we'll create a logic switch tied to SF at -100. We'll just call this gear down, for example. And then now you can actually just tie this logic switch right into your mix without having to use a var or variable. So I'll come over to mixes, I'll add a new free mix, I'll set it to the last position, I'll call that gear. For my source, I'll use the logic switch gear down, and then I'll assign that to an output such as channel 11. And now when I toggle that switch, my gear down logic switch becomes active or inactive, which feeds this mix as the source and drives the output channel. So this programming method may or may not be useful for you. You may just prefer to go ahead and set all of your mixes to your switches and all of your audio callouts to your switches. And maybe you don't share your model files that often. But for somebody like myself that does send my model files pretty often or post them publicly, programming them in this way allows the end user to to make simple modifications to the model templates all from one single spot. And while the logic does seem more complex when you first look at it, once you've built a few model templates in this way, it becomes a lot more understandable once you've familiarized yourself with the functions and features of logic switches, Vars, and how it all feeds back into your mixes. So I hope that this has been useful for you, and this has kind of been a longer video than I normally make. And again, there is really no right or wrong way of programming these model templates, because you may program it a different way and it may function exactly what you need for your needs. So this is just the way that I like to do things, by using some of the logic switch functionality as well as the built-in logic, such as the system events for setting up my special function audio callouts, programming my mixes, and even flight modes. So some people do prefer to just set them all up under the flight modes and have the flight modes, different flight modes, triggering all of these different callouts as well. Again, everybody has a personal preference, and there's really no right or wrong way of doing these. It's just what makes the best sense to
Switch
you.
warning. Throttle cut on.
So in this case, on my FMS Avanti, my timer countdown start condition is when I don't have throttle cut.
Off. Throttle cut on.
So
Throttle cut off.
throttle cut off, my timer starts running, throttle is active, my model timer starts running,
Throttle cut on.
throttle cut on. When I've landed, my flight timer resets, and my model template time, or my model timer, total timer, keeps running and adding, so I know my approximate total flight time that I have on this specific model.